Okay, this is your first introduction into motion and speed. So we will be talking about displacement and motion today. It really depends on based on your motion depends on whatever you're looking at, so your reference point. So motion is any object that moves relative to another object. So if you look at, for instance, in this one, if you have the reference point of the mirror or the toilet, you can see this person, Barry or Barack Obama, moving across the room based on your reference point. So knowing that you're moving based on what you are looking at. So if you're in the car, your reference point would be either the road or the surroundings. So like if you look out to the side and you see trees whizzing by or the lines moving on the road, that's your reference point. That shows you that you are in motion. So how does motion occur? You use that reference point. Now I would suggest if you need more of an explanation on this, go to YouTube, look up reference point example. So like for instance on this one, you're looking at the reference point of a walking person or moving sidewalk type thing. Now distance. I've used this example a couple times. So right across the river, we have the distance of just a few kilometers away is Valmeyer. Now it takes much longer to get there and is much farther distance because of the path we have to take. So the length an object has moved, and this depends on the length of the object. So if we're going to Valmeyer, it's going to be in kilometers. If we're going to go across to the next room that we're in, that's going to be meters. It just depends on how far you're going to go. Now, with Valmeyer, if you were to swim the river and walk, we're only like maybe 4 or 5 kilometers away. But it takes about 45 minutes, so about 40 kilometers to get to Valmeyer by driving because there is no direct path. So displacement is the shortest distance. So this would be as the crow flies type thing. So the shortest distance from the initial or the beginning position to the final position. You must include both distance and direction. So displacement means that it was moved 45 feet to the left, or I walked 17 meters towards the door, or I walked 20 degrees north and 20 degrees west. And that would be my displacement. So that's going to show me where I'm going. Displacement is the farthest that you can go. Distance is the route that you have to take to get there. Now, if we're doing practice, what we're going to do is I move 10 degrees north, and then I move 10 meters north, 10 meters east, and then 10 meters south. What is my displacement? So if I'm looking at my displacement, I'm going to see that my displacement is subtracting north and south because that basically gives me a distance or a opposing ways that I travel. Because if I go north and then I go south, it's going back to my original spot. The movement east is what is actually displacing me. So that's where I traveled. The total distance to get there was 30 meters. Now this could mean that I had to walk around a lake to get to the other side of the lake, or it could mean that that there was a building in the way, something that would help do that. Now, diagram would be something like I went 10 meters north, I went this way, 10 meters east, and then I went back down south. So 10 meters south. And that's so my starting place is here and my ending place is here. So that means this is my displacement. Make sense? Moving on. Let's get rid of that mark. All right. So displacement practice number 2. What is the displacement of the runner and the total distance going? So the meter is 250 meters. Sorry, the track is 250 meters. Now he goes all the way around and he finishes in the same place. So technically, the displacement is going to be 0, but the total distance traveled is 250 because I'm starting and ending in the exact same place. So think about it. Your displacement during the day is 0 because you get out of the bed at whatever time you get out of bed, and then you always end up in that same spot. So through a 24-hour period, your displacement is 0. You may have traveled hundreds of miles, or hundreds of kilometers, but it doesn't matter because your displacement throughout the day is 0. Kelsey is walking to her class. She walks due east for a distance of 52 kilometers, but forgets her assignment. So that means she has to turn around and walk due west the distance of 63 kilometers. She turns around again, walking east for the distance of 94 kilometers when she finally makes it to her class. Now, let's do this together. So that means we're looking at, she starts a certain place. Now, she's going to walk due east for 52 kilometers. Now she's going to have to go back, turn back around, and that means she's going to walk another 11 kilometers to here, because that's a total of 63 kilometers. So it's 11 kilometers. And she has to go back around and go from this point where she picked up her thing to go all the way 94 kilometers to her ending spot. So this means that she has only displaced herself a total of, so if we move from our initial spot, which would be 52 kilometers minus 94, she's only been displaced a total from her start at, so 52 minus 94 minus 52 is going to be a total of 42 kilometers east is her displacement. As if you like my lovely writing. But she went a total of 52 plus 63 is 115 plus 94. So we had a 209 kilometers total in that day. Total distance. All right. Now your practice is due Sunday at midnight. Let me know if you're having trouble with this, and I will happily help you out. All right. That is all for today. Now,